I'm going to work through this worksheet so you can see how these problems should be done. Again, for each one, we're going to draw a picture, set up the trig ratio, and then solve. Side lengths are going to be to the nearest tenth, and then angles are going to be the nearest degree. All right, so first up, a 75-foot building casts an 82-foot shadow. What is the angle of elevation to the sun? All right, so we have a building here, and we know that the building is 75 feet tall, and then there is the shadow of the building on the ground because the sun is right up here, and this is causing, the sun right here is what's causing the shadow. So the shadow is 82 feet. Here's our right angle. So what is the angle of elevation? So we do not know what the angle is. So this looks like tangent. So the tangent of x is opposite, which is 75, over adjacent, which is 82. So we're going to grab our calculator, and we're looking for the angle, which means we have to do the inverse tangent of 75 over 82, and that looks about 42-degree angle. So we're going to say this is a 42-degree angle of the sun. All right, next up, a pirate spots a shipwreck that is 650 feet below the water. A diver jumps from the boat and swims 935 feet to reach the wreck. So what is the angle of depression? All right, so we have our water here. Here's our shipwreck, whatever, down at the bottom, we'll just say. Here's our boat. So the shipwreck is 650 feet below the water. So I know, let me get another color going on in here. Okay, so I know that this measurement right here is 650 feet. Okay, a diver jumps from the boat and swims 935 feet. So the diver is swimming this distance, which is 935 feet. So the question is, what is the angle of depression from the boat to the shipwreck? So that is this measurement right here. So we do not know that measurement. This looks like sine. So the sine of x is opposite, which is 650, over hypotenuse, which is 935. Again, we don't know the angle, so we need to use the inverse sine. So what do we have? We have 650 divided by 935. Did I get that right? Yep. So that looks like a 44-degree angle. So 44 degrees. All right. Okay, you're standing on top of a cliff that is 305 feet above the lake. Angle of depression to a boat is 42. How far is the boat from the base of the cliff? So this seems to be a pretty good measurement right here, obviously. Okay, so we have a cliff, which we'll say is this. You're standing at the top of a cliff. Here's the lake, and there is a boat out here. So here's our boat. Okay, so what do we know about this? The cliff is 305 feet. The angle of depression to a boat on the lake. So this right here is what we're talking about. So this would be the angle of depression. If we think about this right here, the angle of depression is going to be this measurement right here. So the angle of depression to a boat on the lake is 42 degrees. All right. So how far is the boat from the base of the cliff? So we want to know how far is the boat from the cliff, which would be this measurement right here. All right, so two things can happen. We can either keep in mind that the angle of depression and the angle of elevation are the same because those are alternate interior angles. So we can use 42 degrees down here. The other thing that we can do is just take our 90 degrees and subtract it from the 42 degrees, and that will give us the angle that is up in this part right here. So that's another option that we have. So I think I might just go with this one. So I know that this angle up here is going to be 48 degrees. So the angle of depression, remember, is always from like the sky to the line of sight. So, or the top to the hypotenuse going down, because it's a depression, so it's going down. So if I use this looks like tangent right here. So the tangent of 48 degrees is the opposite, which we don't know, over the adjacent, which is 305. So to get this, I need to multiply these two together. So we need 305 times the tangent of 48 degrees, which is 338.7. So 338.7 feet from the cliff. So that's how far the boat is from the cliff. All right, number 4, you're standing 50 yards from a hot air balloon that's preparing to take off. The angle of elevation to the top of the balloon is 28 degrees, so what's the height of the balloon? Okay, so we have a hot air balloon, which we're going to say, oh my gosh. Okay. That's so bad. I don't even know what to do, but okay. But there's your hot air balloon. Oh my gosh. That was awful. I don't even know what I was thinking. Okay, so you're standing, so you're out here, and you are 50 yards. So the distance from the hot air balloon and you is a distance of 50 feet from a hot air balloon that's preparing to take off. The angle of elevation to the top of the balloon, so when we look from the top of the balloon to here, we have an angle of elevation that's 28 degrees. This is obviously not drawn to scale. So the question is, what is the height? So we're looking for the height of the balloon. So this looks like tangent again. So the tangent of 28 degrees is the opposite side, which is the height, over the adjacent, which is 50. So to get this one, we need to do 50, let me clear that, 50 times the tangent of 28 degrees, which is 26.6. So 26.6. Oh, this is in yards, not in feet. So sorry, yards. So the balloon is 26.6 yards. So almost messed up that unit there because I was going to say feet, but this is not in feet. This is in yards. Okay. All right, number 5. I just did a horrible job on that problem, totally. Okay, to measure the height of a tree, you walk exactly 100 feet from the base of the tree and look up. The angle from the ground to the top of the tree is 33 degrees, so how tall is the tree? So this is a pretty common way to measure a tree. So you have your tree. So you are standing out here. So you walked exactly 100 feet from the tree, and you're looking up, and the angle from the ground to the top of the tree. So this angle right here is 33 degrees. So how tall is the tree? So pretty common question that we're getting over and over again. So tangent again, because we don't know the hypotenuse. So the tangent of 33 degrees is the opposite side over the adjacent side. So let's clear that one away. So we need to do 100 tangent 33, and we get 64.9. So the tree is 64 64.9, and that is in feet. All right, moving right along. Okay, number 6. So the Goodyear blimp is flying 400 feet over the stadium. A fan is outside the stadium, looks up at a 7-degree angle to see the blimp. How far is the fan from the stadium? Okay, well, I am like almost afraid to even attempt to draw this. So I'm going to say that here is my stadium. So just pretend here, okay? There's the field in there. Okay, so this is the stadium. There's a fan outside of the stadium. And then right here is the blimp, which is going to look something like that, we'll just say. Okay. All right, so let's see. What we know is that the blimp is 400 feet above the stadium. So that's 400 feet. We know that a fan is standing outside of the stadium looking up at a 7-degree angle to see the blimp. So how far is the fan from the stadium? So we're looking for that measurement right there. So once again, looks like a tangent. So the tangent of 7 degrees, is the opposite over the adjacent. So this time, to get this answer, I need to reverse those. So I need to do 400 divided by the tangent of 7 degrees. So he is 3,257.7. So I need to keep this because I'm not going to remember that. So 3,257.7 feet away from the stadium. All right. Okay, an airplane is 4,000 feet above the ground with a 12-degree angle of depression to the runway. So what is the ground distance between the airplane and the runway? Okay, so we have the runway out here. So here is our airplane, which, you know, I'm not going to be able to draw an airplane, so we'll just pretend. There's my airplane. So the airplane is 4,000 feet above the ground. So we know this measurement right here is 4,000 feet. There's a 12-degree angle of depression. So keep that in mind, that is the 12 degrees because the angle of depression is going to go down. All right. So what is the ground distance? So the ground distance is this one right here, which is what we're looking for. So remember that we have two options. The angle of depression and the angle of elevation are the same because those are parallel and alternate interior. So for this one, I'm going to use the 12 degrees down here. So once again, it looks like tangent. So the tangent of 12 degrees is the opposite over the adjacent. So again, I need to exchange those. So for the answer, I'm going to do 4,000 divided by the tangent of 12 and 18,818. Okay, so hold on a second. So 18,818.5 feet is the ground distance. So that's the distance from along the ground, not in the air, but along the ground. All right. Okay, number 8. Princess is held captive in a tower. Knight in shining armor is on the ground with a ladder. He sets the ladder at its safe 75-degree angle with the ground. He's 12 feet from the base of the tower. So how long of a ladder does he need? Okay, so here is our tower, because that's what I feel like it should look like. All right, so we have the knight who's down here. Okay, so he has a ladder. So this is the ladder right here. And he has a 75-degree angle with the ground. And he is 12 feet from the base of the tower. So how long of a ladder? So we're looking for that one. All right, so finally we have something different. This one looks like cosine. So the cosine of 75 degrees is adjacent over hypotenuse. so again, I'm going to switch those. So I need to do 12 divided by cosine of 75, 46.4. So 46.4 feet is the requirement for a ladder. So ladder has to be at least that long. Okay, Mike and Dave are taking measurements of a road for some civil engineers. They need to know how much the land slopes downward. Okay, so Dave walks 80 feet down the road from Mike and holds a measuring stick marked in inches. Okay, so we have a change in units here because that's feet and inches. Looking through the sighting instrument set parallel to the horizon, Mike can see the measurement of 50 inches. So what is the angle of depression? Okay, so here's the deal. So we have the road that goes like this. Okay, so that's serving as our hypotenuse. So here is Mike. Dave walks 80 feet. So that is a distance of 80 feet right there. And then he is going to hold up a pole that has measurements on it. All right. So then Mike is looking through. So here's his line of sight. His line of sight is parallel to the horizon. So here's our right angle right here. So when he looks out, he can see a measurement of 50. So this is 50 inches right here. So the question is, what is this angle? All right, so Dave walked 80 feet down the road. He's holding up a stick that Mike can see looking straight out, parallel to the horizon. He can see a 50-inch mark. All right, so first thing that we probably want to do is to change our inches into feet. I would think that that would be, well, let's see. But that one's not going to be a good measurement because that's going to be 2/12. But, okay, so let's change 80 feet into inches. So to do that, we need to multiply by 12. So this is 960 inches. All right, this one's a repeating decimal, which is why I didn't change it. All right, and then we're looking for the angle right here. So this looks like sine. So the sine of x is the opposite, which is 50, over the hypotenuse, which is 960. So since I want the angle, we need to do the inverse sine of 50 over 960, and we get 3 degrees. So this is a 3-degree elevation of the road. All right, last one. Your family's camping tent has a center pole, 62.5 feet, 25. If the sides are at 50-degree angles with the ground, how wide is your tent? Okay, so I'm thinking here is the tent. Here's the ground. All right, this pole right here, which is in the center, is 6.25 feet tall. Okay, we know we have a right angle right here. We know that this is 50-degree angle right there. So what we need to do is figure out this measurement, and then we have it twice. All right, so looking at that, that looks like a tangent again. So tangent of 50 degrees. The opposite side is 6.25. The adjacent, we don't know. So I need to swap those two out. So I need to do 6.25 divided by the tangent of 50 degrees. That gives me 5.2. So 5.2 feet. So how wide is the tent? If this is 5.2, then the tent is 10.4 feet wide, because that is only giving us half of the tent when we solve that one. All right, I hope that helps you out.